Let's sort 5, 1, 4, 2, and 8 into 1, 2, 4, 5, 8, but this time much faster. Merge sort uses a divide and conquer trick. If a list is big and messy, we cut it in half, sort each smaller half, and then carefully merge the two sorted halves back into one. Merging two already sorted lists turns out to be surprisingly easy. Here's the idea. We keep cutting the list in half until every piece is just a single element, and a single element is trivially sorted. Then we build back up. To merge two sorted halves, we look at the front of each and take whichever is smaller over and over. Because both halves are already sorted, the smallest value overall is always sitting at one of the two fronts. That is the invariant that makes the merge correct and gives us a fully sorted list at the end. If the list has one element or none, it is already sorted, so we return it. Otherwise, we find the middle and sort the left and right halves by calling ourselves. Then we merge. Two pointers walk the fronts of the halves, and we keep appending the smaller front value. When one half runs out, we tack on whatever remains of the other and return the merged list. Let's build it live and watch two sorted halves merge into one clean list. A list of one is already sorted. Otherwise, we split at the middle and sort each half by recursion. To merge, two pointers walk the fronts of the halves, and we always take the smaller front value. When one half is used up, we append whatever remains of the other and return the merge result. Now let's test it and hit run. And there it is. 5, 1, 4, 2, 8 becomes 1, 2, 4, 5, 8, built up by merging sorted halves. Here is the shape. If the list is tiny, it is already sorted. Otherwise, we split at the middle, sort each half the same way, and then merge the two sorted halves into one, which we return. Why is this fast? Having the list again and again gives about log n levels, and at each level we do n work to merge everything back together. So the total is order n log n time, much better than n squared for large lists. Trade-off is that merging needs extra room, so it is order n space. 3 things to remember. First, the base case, a list of length 1 or 0, is what stops the recursion. Second, compare with less than or equal in the merge, which keeps equal values in their original order, a property called stability. And third, after the merge loop, do not forget to append whatever is left over in the longer half.